All right, y'all, let's do this box being pulled by a force, and we want to know the friction force on it. So remember, we gotta do our little free body diagram. So we've got F here at an angle phi, and I'm going to split that into two pieces. I'm going to have the F cosine phi component and the F sine phi component. Ooh. All right. Then I've got the friction force going backwards, and I've got the weight going down like this. So let's be clear. I'm going to have F sine phi equals the friction, and I have, equals the weight force. You know what? There's one more force missing. We've got a normal force here. So let me rewrite that equation. Silly me. There's a normal force right there. Ah, can't believe it. So we have F sine phi plus the normal force balances the weight. Let's actually calculate that normal force. That normal force is going to end up being mg minus F sine phi. And then in the horizontal direction, we're going to actually, you know what? It doesn't really matter too much for now. Let's get the friction force. The friction force is going to be mu k times n. So F is going to be mu k mg minus F sine phi. Any of those choices on there? Woo! Letter E. Good for us. All right. Now, number 13. Ooh, we are accelerating from rest and reaching a speed of 30 meters per second in 6 seconds. We want to know how far the car has traveled in that 6 seconds. So I will say x is 1/2 a, which is 30 divided by 6 times 6 squared. And it's going to give me 1/2 times 5 times 36. That's going to give me 180 meters. Wow. All right. And then number 14. What does it even look like? Let's see. Okay. If an object is moving in a straight line, if the speed of an object moving in a straight line is increasing at a constant rate, the net force acting on the object, well, let's be clear. This means a constant acceleration. And if F is ma, that means we have a constant non-zero force. Pretty annoying, huh? Alrighty. And in the next video, actually, no, let's do one more. So we have a 20 kilogram block moving at an initial speed of 10 meters per second, and it comes to a stop. So let's just see something here. Let's just get the acceleration of the block. I don't know, I'm just kind of moved to do that. So here we go. We have v squared equals v naught squared plus 2ax minus x naught. So we're going to get 0 equals 100 squared plus 2 times a times 25 minus 0. So we're going to get 1,000 divided by 50 is going to be a. And so my a ends up being 20 meters per second squared. Seems kind of big, but whatever. I guess I'll go with it. Now let's be clear here. The friction is the cause of the acceleration. So that means friction equals ma. So here we're going to have mu mg equals ma. That's mu times the normal force, because this is a standard normal force weight friction problem where normal equals the weight. So the m's cancel. We're going to get mu times g equals a. Seems like I did this completely wrong. So where did I go wrong? Aha, it's not 100 meters per second squared. It's 10 meters per second squared. So my acceleration is actually 2. So a is actually going to be 2 here. So when I actually solve, I'm going to actually end up getting that the answer is 0.2 for my coefficient of friction. And then which way does the frictional force and the floor frictions act? Well, the friction force on the box, since we're moving to the right, friction force will go to the left, so it's got to be one of these. And then there's going to be an opposing friction force from the third law going to the right. So that is the correct answer by Newton's third law. All right, we will finish up in the next video.